This is the first of 3 lessons on the quadratic equation. We're going to look at the quadratic equation in standard form, where we have ax squared plus bx plus c equals 0. A, b, and c are constants, and a does not ever equal 0. If it did, you wouldn't have your variable being squared, so you wouldn't have a second-degree polynomial, therefore you wouldn't have a quadratic equation. We're going to look specifically in these 3 lessons at ways to solve a quadratic equation. And there's 3 main methods of solving. The first, which this lesson will cover, is factoring. The second is on completing the square. And the third lesson will be that of the quadratic formula. So let's look first at solving by factoring. To do this, we need to review the 0 product rule, that if you have 2 factors whose product is 0, then either one of the factors equals 0 or the other factor equals 0. And it doesn't even matter, there could be 3 or 4 or 5 factors. That the main thing is that when you have a product of 0, at least one of those factors must equal 0. So let's look at this quadratic. I can see that it's a quadratic because it's a second-degree polynomial with just one variable, and it's in standard form because it equals 0. So once I know that it's in standard form, and that's absolutely imperative for doing factoring, it has to equal 0, it has to be in standard form. I now factor the left-hand side. I see that both of those terms have an x, so I factor out the x. Now I have 2 factors, and remember the 0 product rule says that if I have 2 factors that equal 0, their product is 0, then at least one of the factors must equal 0 or the other must. So either x equals 0 or 2x plus 7 equals 0. So I'm going to solve the first one, x equals 0, that's already solved for us, so when x equals 0. So the second one, 2x plus 7 equals 0, I'm going to solve for x in that equation, and I get that x equals negative 7/2. There's a format here always that when you just have a first-degree equation, basically a linear equation, that equals 0, the solution will always be that x will equal the opposite of the b divided by the a. So that's just a quick way to look at how to solve for a linear equation that equals 0. So I know that the solution to this quadratic is x equals negative 7 or x equals 0. And what that means, so that we truly understand what solving means, is that to make this statement true here, this quadratic, 2x squared plus 7x equals 0, to make that true, the value of x must be either 0 or negative 7/2. There's no other values for that variable that will make that statement true. Let's look at another example. Now notice that this is not in standard form. So the first thing I have to do is get this equal to 0. It must be in standard form. Now I can see that it's in standard form. And I notice that all 3 of those terms, 16, 114, and 14, are all divisible by 2. So we want the smallest we possibly can. So factor out anything that's common in all the terms. Now we have a simpler equation to factor. And you could use the diamond box factoring, which we've discussed in class, but I'm going to be only using this grouping method in this video to help people remember what that's all about. I pick one of the numbers. I notice that 7 is a prime number. So I know that if I do 1 times 7, it's the only way to get 7. So I know that in these groups I'm going to have a 1 and a 7 there. The next thing I note is that I have the positive here in front of 7. That means that inside here, in these 2 areas, in this spot and in this spot, it's going to be either a plus or a minus, but it's going to be the same. When this is plus, that means both of these factors will have the same operation going on here, either addition or subtraction. And the second symbol, this one here, tells me what the sameness will be. And so that sameness is going to be negative. So they're both going to be subtraction problems. And now I have to look at these, what I call the smiles, the products that I'm going to add up. And they have to add up to equal the middle term. So I picked numbers that, when multiplied, give me 8. I could do 8 and 1, so I could put an 8 here and a 1 here. And then I would multiply those and check them out. But I can see that 8 times negative 7, well, maybe that will work. I don't know. Let's try it out. 8n and 1n, and we check it out, and we do the multiplication. Oh, it works out just fine. negative 57n when I add them together. So I know that that is the factoring of that polynomial. Since the product equals 0, I know that either that factor equals 0 or the other factor equals 0. So I solve each of those equations, and I know now the solution to this original equation up here, to the solution to this problem, is one of these two solutions. It's either that n equals 1/8 or n equals 7. Either one of those will make the statement true. Let's look at another one. Step number 1 is to get this equal to 0, and so I'm going to subtract everything that's on the right-hand side so that it equals 0. And now I'm going to look at factoring. There's nothing common. 35, 69, and 28 have no common factors. So it is already relatively prime is what we call that. They have no common factors. And now I have to pick either the 35 and figure out what's going to multiply that and put the two factors, one here and one in this group. Or I could look at 28. 28 has more factors. So I'm going to look at 35. And 35, it's either 1 times 35 or 5 times 7. I'm going to try the 5 and 7 first. So this is kind of, I call this method really, it's factoring in groups, but I think of it as guess and check. We just kind of pick a couple and then we say, all right, we've got the clues here. Remember that it's going to be the sameness, and then we're going to find that that sameness is subtraction, so I can put that in there. I put my two little smiles that I'm going to find those products, and I first try for, I'm looking now for numbers that multiply to give me 28. Well, it could be 2 and 14, so I try that, and I get, well, negative 2 times 7 is negative 14, and 5x times negative 14 is negative 70x, and nope, that does not give me negative 69, so I have to try something different. So how about 4 and 7? Well, when I multiply those, I get negative 28x and negative 35x, and no, what is that? That's 63. That doesn't work. So that's not going to work. So then I change the order, and I said, well, what if I put the 7 on the left and the 4 on the right? Try that out. Yes, indeed, I get negative 69x. So like I said, this is just kind of a guess and check. I'm looking at the product of these two groups and seeing that they add up to the middle term. And now I'm going to solve for each of those factors that must equal 0. And so I have the solution to the original quadratic equation up here, which was not in standard form, but the solution to this equation, this will be true so long as either x equals 7/5 or if x equals 4/7, it will be true. So here's some problems that I want you to solve by factoring. You're going to need to write each one of these down. The solutions are not in this video. I want you to write each one of these down, and I want you to solve them. And you're going to now, after this video, make sure you go to the website, and you're going to take a Vid Q. And in the Vid Q, you're going to tell me the answers to each one of these problems. We will then go over them in class to make sure that you have the solutions correct. That's the end of the first of 3 lessons, this one being solving by factoring, solving quadratic equations by factoring.